Alright, you're welcome back again. So this time around, I want to look at what is called allometry in past. Allometry. If you are not into morphometric analysis, you will not understand what allometry means. It simply means effect of size on shape. Okay, effect of size on shape. So I want to look at allometry. So I want to first emphasize that past is not the best application to uh, observe or present allometry. Okay, I want to show how to do it properly using Morpho later as we continue in these classes. But past is not the best, but I will show you how it is done in past, but I will now do it properly using Morpho later. So, but I want to let you know that the past is not the best way to show allometry if you want allometry. So let's see how it is done. Allometry is done using the main image shape, okay, the real landmarks, the raw landmark you have generated using your your ditch or whatever that you use to generate it or how. So, but this is just a PCA. We're going to use the real data set. I mean, your real landmark. So I browse it here, open it. So I have it here. So all landmarks here. I open it so you can see it here. So now, for me to do that now, I need to uh, include. Okay, let me first select all, and here I'm going to go to transform landmarks 2D. So now I'm going to add one more size here. I had here column. I need the size column here. Okay, and when I do that, I'm going to click on OK. So automatically the size will be included. Can you see the size now? See the size column. Okay, it's included here. Okay, so this is size. It's called central size, centroid size. All right, this is centroid size of each of the uh, specimen. Okay, this specimen is size, this size. So each of them have its own size, and they have SY component of each of the uh, points we have landmark or annotated. Now we want to also do that because when you are doing allometry, you may need to include color for the category. So we're going to include that here. Let's go and copy our race here. Copy our race here. We want to include that here because you see the same thing. So we just come here, we click here, then we click here. We say okay, we insert. Let's say from here, say come here, we insert new columns. Okay, insert columns here. One column, just one. Okay, so we want column to be here. So we click on this place, this C1, click here, click on paste. All right, our race is it's a group variable categorical. So we check this, then we can uncheck back now. All right, so that is done. So you can now color it as usual, edit, then color replace. So let's make it black, this one blue, okay, this one maybe let's say coral. Okay, so close. So we have that is out. So now you can now select all. Most time, okay, let's select all first. Okay, because sometimes when you select all, some spaces may be selected together with it, which is a might be just empty space. But so you may need to select it one by one. So, but let's just select and click on geometry here. Go to 2D, then click on allometry components. Click here. All right. So here we have our allometry here. As you can see, eigenvalue and the variance is shown here. All right, then we also have our scatter plot here. Can you see our scatter plot for allometry? This common allometry component, this residual shape component one. This CSC is general for all of them. All right, so but this one can be changed. Okay, can change this one. Okay, change this one. This allometry. So can change this one. So can go for eigenvalues or not. So this is the score. So this score can be downloaded, can be copied, and put in Excel and plotted for each of the one each AC for each of this category of this column. Okay, you can do that. Okay, this is the formation of the this is for me the formation. You can see it here. So this is the shape, right? So this is just what you need to. But for the skin plot, you don't need that. Okay, you don't need skin plot, right? But what you need is scatter plot and the score. If you want the score, the formation. If you want this formation, the summary. So we have a CAC of R2 of 0.499. Okay, so if you don't, if you are not to movement analysis, you don't understand all these things. For those who are in the field, they understand what I'm talking about. Okay, so you can get this particular report. But as I said before, this is not the best way to handle allometry in morphometrics. I'm going to do that using another application called MorphoJ, so we can see the proper result. How better to see the significance of the of shape of size, the central size on the shape. Okay, so that is that for now. I will see us in the next class. Thank you so much.